Welcome to Callous Coder. Last time we created a hello world in ARM32 assembler. Today we will extend that code by creating nice clean functions and creating our own toUppercase function. Motherfucker! So we're going to pick up where we left last time. Last time we created this little program that writes hello world to the screen. This is the code from the GitHub with all the nice comments, so link in the description. We're going to build upon this to create nice functions and to create our own function that turns it into uppercase. So it's a nice little academic challenge, it's rather simple. So let me get the C code to show you what we will be doing. Here's the C code. So this is what we had last time. We have a string with a fixed length. Now we're going to create a secondary string, or at least create the memory for that. That will hold the uppercase string. Then we will iterate through each character of the string and check whether it's between lowercase a and lowercase z, with those values inclusive. If that is the case, then we subtract 32 from it, because the lowercase values are 32 above the uppercase values. If it's not a lowercase a or z and the letters in between, then we just copy it into the result string, because then it's already uppercase or a symbol that we do not want to translate. And then for the sake of fun, we will print it 65535 times. So that is what we will be doing. And we will be refactoring our old code to also create some functions into it, because that is a very good practice to have functions. So let us do that first. Let's first clean this up to create some functions for the print. So I want to have the R1 and the R2 to be parameters, and the R0 will already be fixed to standard out, so we're going to remove that and we're going to call this print function R1 contains string pointer, R2 contains length. I already have the code written, and the link is in the description with all the nice remarks. But just for completion's sake, now we need to do something. We need to push the link register. We're still not using stack frames. Stack frames allows you to push data on the stack. Since we not need to do that over here, we can just pass the variables in the registers. So far we can just get by the easy way. We push the link register, BL, that is calling a function in ARM assembler, and it stands for branch with link register. It will set the next instruction below the BL instruction into the link register. And we're going to push that onto the stack so we can pop it into the program counter when we're done. So here we're done, and we say pop it into the program counter, effectively removing it from the stack and jumping back to the next instruction below the BL. And here we have the exit instruction that we also want, so we want to have the push with link register. Then we want to pop it into the program counter, and we have R0 contains exit code. Alright, and now we need to create our own toUpper function, and we also need to store the link register and then pop it into the program counter. So first we now can load, what we want here is x0 source string pointer, not x0, that's 64 bits. I will probably do that wrong a lot because I usually code in 64 bits. R1 is the uppercase string and R2 string length. So we can load x1 with the string like we did last time, x1 with the uppercase string, and we have not created that, so we're going to create that after we also load see me and 64 bits. I've been using 64 bits since the late 90s on alpha systems, so my mind has been wired for 64 bits. Len, alright, and then we will just call branch with link to upper, then we will do the print, and we will do the exit, and let us also immediately load R1 with the uppercase string, and R2 is still that same len, that way we have it already set for the print statement. And here we need to do a little assembly trickery. We say we want to create an uppercase string, and we will do that with the .fill. It is len position long, the position is 1 byte, and we want to fill it with 0. So basically we're creating 28 in this case, 1 byte values, and we set that on into 0. So an empty string. Right, so now let's implement the toUppercase. So first we need to read a byte from the string. We can do that with LDR, B for byte. And we want that in R3. And we read it from the R0, because the R0 is the source that points to the string. And after reading that, we will increment that R0 pointer with 1 byte. So we move to the next character. That is all done in a single instruction. That's brilliant. Okay, now we need to compare whether the value in R3 is of the literal value A. The single quotes will translate that value A to the, in this case, binary number 97. And if it is greater or equal, because we want the A also, then we go to upper, and otherwise we can jump branch to just store, because then it's obviously a character that is not within the range. So we're going to make the store here and to upper, and let's first do the store because that's simple. That is store B for byte. What is in R3, we will store that to R1, and we do the same thing. We will increment the pointer that R1 is pointing to with 1. Okay. Then there is still something that we need to do here later on, but we get to that. Oh, it's still added. Okay. Now we need to compare whether it's not greater than Z. Otherwise we have a problem. Because we don't want to change the values that are beyond the Z. So we need to compare R3 with what is Z. If it is greater than, not equal, because we want the Z also to be capitalized, then it's something that we don't want to change, so we just jump to store. And otherwise, we have basically everything between the lowercase a and the lowercase z, including those two. And then we need to do a subs. Now the funny thing is there is a sub and a subs. The difference is that the subs works on the status registers. So if you do a subs and it becomes 0, then it will just set the 0 flag. I often forget the S, and when you do a loop, then you loop forever because it doesn't act on the 0, so you do not branch on the branch not equal. So I forced myself to use subs, although this is one of those cases that you can buy with the sub. And we want the value in R3. We want to subtract from R3 the number 32. So what is happening here is we take what is currently in R3, and this can be any register, and that is cool about ARM assembler. It's not as constructed as x64 where certain registers only do certain things. No, you can basically use any register. So we use what is in R3, we take away 32 from that and we store it in R3. And you could even store it in R0, for example, if you like. That is the cool thing about ARM assembler. And yeah, then we just store that in that, but now we would just do it only for one character. We also need to subtract, and here the S is very important, from R2 into R2, the value from R2 minus 1. So that is basically going through the length of the string. We iterate this that many times. And then branch not equal underscore toUpper, whatever. And that needs to go here, because we don't want to jump all the way to the top, because then we would keep pushing stuff onto the stack, and that's a bad thing. So I think this should be it. Then we pop here. Let's see if it makes which errors I have created. Ooh, no. And we have a capital string. Yeah, easy peasy. So now we just need to do the loop thing. So let's create a label loop. And let's use which register isn't used, R3. So let's say we move in R3 the literal value 0xFFFF. We do that same trick we just did, subs from R3 the value R3 by 1. And if it's not 0, branch not equal, equal means that the 0 flag is set, underscore loop. So now we should have 65,000 of them. And there it goes. Oh wow. And this time I wasn't interrupted by annoying sirens. Yes. So I hope you liked this episode, and see you in the next one. We will probably be doing the 64-bit version, which basically is just changing the registers from R to X. That is the cool thing. And we can use a red instead of a pop PC. That's also cool. So, see you in the next one.